We say that the stick is directly on the plane we are drawing. The hash represents substituents that are at the back of the plane we are drawing, and the wedge represents substituents that are in front of the plane we are drawing. So let us look at this stereogenic center. Hello everybody, my name is Owechidozie Godwin and I'm your tutor for today on Academy X. So today we are going to be looking at Stereochemistry, chapter 2. I'm going to be continuing from where we have done in chapter 1. So for chapter 2, the first thing we are going to look at is chiral molecules with stereocenters. Chiral molecules with stereocenters. Now, we have two types of chirality. We have two places where we can exhibit chirality in compounds. We have point chirality and we have axial chirality. So we want to be dealing with the first one for now. In subsequent videos, we are going to see what axial chirality is. Now, in point chirality, it is a type of chirality centered on a single atom. It is a type of chirality centered on a single atom, and that single atom must have 4 different substituents. That single atom must have 4 different substituents, in the sense that if you repeat any substituent, that particular compound ceases to be chiral. Now, this single atom where chirality is expressed is called the stereocenter or stereogenic center. So that particular atom where we express chirality in an organic compound or in any compound is called stereocenter or stereogenic center. Now, this center holds a set of ligands in a spatial arrangement. What do we mean by spatial arrangement? Spatial arrangement means arrangement in space. Spatial arrangement means arrangement in space. So how a molecule is arranged in space is spatial arrangement. So this center will hold ligands. How many ligands did I say it should hold? 4 different ligands or substituents. So when it holds them in spatial arrangement, and in this spatial arrangement, it is not superimposable to its mirror image. If you want to know what superimposable to its mirror image means, you can refer back to our last lecture. Chiral centers can be on the following atoms. It can be on a carbon atom, which is the most common stereogenic centers we have in compounds. It can also be on nitrogen. It can also be on phosphorus. It can be on silicon. So these are atoms which can have this stereocenter that can be able to express 4 different substituents in spatial arrangement. I hope we are following the lecture. Okay. Now, in the next board, we have skeletal formula. Skeletal formula. Now, we will represent stereocenters using skeletal formula. Now, skeletal formula can be made up of 3 different types of bond. We have the stick bond, we have the hash bond, and we have the wedge bond. We have the stick bond, we have the hash bond, and we have the wedge bond. Now, the stick bond is a type of bond that is relative to the plane we are drawing the skeletal formula in the sense of this aligns with the plane we are drawing this formula on. Now, hash bond, which is represented like this, you can see how I'm drawing it on the board, is a type of bond in which the substituent we represent with this is directly at the back of the plane. This one is on the plane we are drawing the skeletal formula on. This one is at the back of the plane we are drawing the skeletal formula on. And the wedge bond, which is drawn as this, is the plane, which is the substituent, which is in front of the plane of the skeletal formula we are drawing. So let's take it again. We said that the stick is directly on the plane we are drawing. The hash represents substituents that are at the back of the plane we are drawing. And the wedge represents substituents that are in front of the plane we are drawing. So let us look at this stereogenic center. Can you remember when I said that a stereogenic center is a center that holds 4 different substituents in a spatial arrangement? So the spatial arrangement here means that A is a substituent on a stick bond. This substituent is directly on the plane we are drawing this skeletal formula. B is also on a stick bond, which is directly on the plane we are drawing this skeletal formula. Now E is what? Hash bond. E is directly at the back of the plane we are drawing. So this kind of structure, we see that E is at the back of A, C, and B. Now the last one is D, which is on a wedge bond. Now D, we can see that D is directly in front of the plane we are drawing this skeletal formula. So that is the introduction of skeletal formula. So let's look at this. We said A, B, C, and D. It is a must that there must be 4 different substituents. Any repetition of substituents, example, replacing this one with A, turns this center to be a chiral. It makes it lose its chirality. So this particular stereogenic center must have 4 different substituents. It must have 4 different substituents. You can say that this is A. Now, let us look at this skeletal formula in a cyclic compound. This is a straight chain compound. So let us look at it in a cyclic compound. So these are stick bonds. Let me circle them. These are stick bonds. These are stick bonds. These stick bonds means that this particular substituent or this particular ring we have here is directly on the plane of the skeletal formula we are drawing. Now, this particular bond is a wedge bond. So what does it mean? It means that it is directly in front of the plane we are drawing. And then this particular bond means that this particular substituent you can have here is directly at the back of the plane we are drawing the skeletal formula. So let us look at how we can comfortably present this hash and wedge bond in a way that when we are drawing the skeletal formula, we are not going to lose mass, because you know that the exams are now paper-based. So you must draw these structures in your exam. So there's a rule you must follow, that when you have hash and wedge bond, there must not be opposite. There must be adjacent. So opposite means something is here and the other one is there, while adjacent means they are on the same place but they are separate. Now let us present it. This is adjacent. Hydrogen substituent is adjacent to fluorine substituent, and both of them are on the hash bond and on the wedge bond respectively. So we say that this is a good presentation of this compound. Now let us look at this. The hydroxide and the methyl groups are adjacent to each other, and the hydroxide is on a hash bond while the methyl is on a wedge bond. So they are adjacent to each other, and we can say that it is a good representation. Now let us look at the wrong representation, where if you draw such structure, you are going to lose marks. Now, if you have a hash bond, chloride is on a hash bond, and we have a wedge bond, hydrogen is on a wedge bond, and we draw it opposite the two sides of the plane, it is a wrong correction. So I guess we can actually know how we are going to correct this by actually erasing this part and then bringing it here. So this will be the correct representation. So let us look at this. The methyl group is opposite the hydrogen group, and they are on hash and wedge bonds. So this is a wrong representation. So if we want to draw this very well, we are going to clean this one that is opposite and draw a hash bond. So this is now the correct representation. So I hope by the end of this particular video, we're able to know what a stereocenter is. We are able to know how it is in a spatial arrangement by this skeletal formula I've been drawing, and we have been able to correctly represent hash and wedge bonds on a skeletal formula. So anticipate the next video for the next lecture.